let me show you an example of how you calculate the Fourier series for a given function from negative pi to pi. So you have to use these formulas. AN is computed by 1 over pi, integration from negative pi to pi, of f of x multiplied by cosine nx dx. And Bn is computed by doing 1 over pi of integral from negative pi to pi of f of x sine nx dx. And once you get these numbers, an's and bn's, then the function f of x can be represented as a0 over 2 plus summation of n equals to 1 through infinity of an cosine nx plus bn sine nx. Okay. And once you find out the values of a0, an, and bn, that's going to be called the Fourier series of this function. So you're just calculating this. That's pretty much all. But before I do that, let me make a few more comments. So first of all, the formulas for the Fourier series are actually somewhat different from version to version, especially if you're taking the communications class. Who here are electrical engineers? Okay, yeah. So for those of you who are in the EE program, will later take a communications theory class, and over there you do a lot of Fourier transform. And for that class, often, actually in most of the engineering, when you use Fourier transform or Fourier series, you don't integrate from negative pi to pi. Rather, you integrate from 0 to some number L. And because the integrating domain is different, the formula will look slightly different. Moreover, what happens is that, see, this is not the most general formula. You could kind of make a more general formula with negative L to L, 1 over L, and they will be slightly different. But that's same as, if this is a periodic function, that's same as integrating from 0 to 2L. So there's a variant of these formulas where the integration is not from negative L to L, but 0 to 2L. Now the reason we like negative L to L is because we want to make use of the even and odd functions last time. Because if you make use of them, sometimes you can save time in doing calculations. You'll see when I do the calculation. So that's one reason. Now another thing that you have to know before you do the calculation is that while I'm giving you only 2 formulas, this one formula is actually 2 formulas in one. Because when n is 0, what happens if you plug in 0? What do you get here? 1. And you just have an integration of f of x, which is very different from when you have fx times cosine. If you have fx times cosine, most likely you will have to use tabular integration. Whereas if just fx by itself, then you don't need tabular. So you have a completely different integral. That's why when n is 0, it has to be computed separately. Now you might ask, then what about b0? What happens if you try for b0?
0.
You get sine of 0, which is just 0, right? So b0 is always 0. That's why you don't see b0 in this formula. Still, some of you might be puzzled why you have this 2 in the denominator. And let me take a moment to explain why you have this 2. That's because it has to do with the average value of a function. Does anyone know how to get an average value of a function? So if you have a bunch of discrete values, then it's easy, right? It's like if if you have a function that's like here 10, here, let's say it's defined for 1, 2, and 3, and 4, and it's like 10 here, and then 20 there, and then 15 here, and then 5 here. What's the average of this function? This discrete value function, what's the average? 10 plus 20 plus 15 plus 5 divided by 4, right? So 50 divided by 4, what's that? Well, 12.5? Yeah, right. Okay. So that's how you do it. But what if you have a function that's like on an interval a to b, and you have a continuous function? How would you find the average? You have to add up everything, right? How do you add everything over an interval? It's the integral, right? So you have to integrate. So if you have such a function, you have to integrate the function from a to b, but then you have to divide by something. What would you divide by?
Minus a.
The interval length. Right? B minus a. Yeah. B minus a, that's the interval length. You divide, that's called the average value of the function. And it does it does make sense if you have a function that's like this. If you have a function that's like piecewise constant over this interval, you'll see that this interval length is 4, and then you integrate, then this is like 10, 20. So these two definitions do coincide if you have a function that's like having constant values over intervals. Now, the reason I'm talking about this is because think about the average value of the sine function over one interval. What would you get? And that one doesn't require any calculation. It's just intuitive. What's the average value of this function over this interval?
Zero.
Huh? It's 0, right? Because you have some portion above 0, some portion below the 0. So if you take the average, it will be 0. How about the cosine function?
Zero.
It will be 0 again, right? So you see that if you just look at this side, which is just a bunch of sums of sines and cosines, the average will be
Zero.
0. Which means that if you have a function which doesn't have average 0, then there's no way for this to equal to that. Okay? That's why you have to put a constant so that the average does work out. So what really happens in this formula, in the Fourier series, is that this value right here is really the average of f. Now once you understand that, then this formula makes sense because, see, if you have a function defined from negative pi to pi, what's the average? You integrate against 1. There should be 1 because n is 0, right? If n is 0, you get 1 times f of x integrated from negative pi to pi, divided by, what should you divide by? Oh, come on, say it. Some of you said the right answer. You just have to say it louder.
2.
What's this interval length?
2 pi.
2 pi. So you have to divide by 2 pi. Right? You have to divide by 2 pi. Well, it's only dividing by pi, right? So there is a discrepancy of what you want, which is the average, and what this will calculate when you plug in n equals to 0. If you plug in n equals to 0, this will give you twice the average, so that's why you have to divide by 2. You need a 2 there, so that's why you put a 2 later. That's why there's this 2. Now, because this is kind of unnatural, some people, in some textbooks, you would see these formulas for n1 or greater. These are only for n1 or greater, and they would provide a separate formula for a0, which version has the 1 over 2 pi instead of pi. For that, they are not going to put a0 over 2, but they're just going to get a0 because it's already it's already just a0. Okay. All right. Okay. So that's another reason why you are going to see different formulas for Fourier series. So if you are taking a class later and Fourier series comes up and you're like, okay, I think I understood this very well, and you go back to my videos and you look at the formulas, if they look very different, well, even though I'm doing the same thing, Fourier series, just understand that you just have to follow the given formula in your textbook, unfortunately. You have to get used to different versions of the Fourier series. Okay, so once that's done, now for the actual calculation of the Fourier series, we're going to always start with A0. We do that so that we don't forget that A0 has to be calculated separately, right? So we are always going to do A0 first. And in our case, the integration is 4x squared plus 5x, that's the function f of x, times cosine 0, which is just 1. And this integral, well, of course I can just find the antiderivative and plug in the endpoints, but see, as I said, we like the symmetric interval because I can use even and odd, okay? So actually one of these two I can just neglect. Which one?
5x.
5x. That's an odd function, right? That's an odd function, so we don't care because that's going to give you 0. If you integrate an odd function over a symmetric interval, that gives you 0. What about an even function? Is there a shortcut for that? You double the integral over the half of the interval. So instead of going from negative pi to pi, we take half the interval, but you just double it. That's possible if you have an even function. And then this integral is what? 4 over 3x cubed times 2 over pi. And you plug in pi and 0. And then pi cubed divided by pi, that gives you pi squared. 2 times 4 is 8, so you get 8 over 3 pi squared. Okay, so we have our A0. Now let's go for AN. AN would be 1 over pi, negative pi to pi, 4x squared plus 5x, cosine nx dx. But again, cosine is even. Even times even gives you even. Even times odd gives you odd. So even times odd number gives you odd function. Odd function times even function gives you odd function. So that's going to go away. Again, that's gone. And you have 2 over pi, integration from 0 to pi, of 4x squared of cosine nx dx. Now for this one, you should use tabular integration. One of the reasons I taught you tabular integration in the beginning of the semester is because, especially when we have to calculate the Fourier series, it's really hard to use the traditional integration by parts because you end up having to do them a lot. So try to use tabular if you can. 4x squared and cosine nx. If you differentiate, you get 8x. Differentiate, you get 8. Differentiate, you get 0. Integrating cosine nx gives you 1 over n sine nx. Integrating this, you get 1 over n squared, actually minus 1 over n squared cosine nx. Every time you integrate, 1 over n comes in front because n is in front of x. Integrate again, you get negative 1 over n cubed sine nx. The first column keeps track of the alternating signs. And once you're done, you can multiply like that, multiply like that, multiply like that. So you have positive 4x squared times 1 over n sine nx, so it's like 4x squared over n sine nx. And negative times negative is positive, so you have 8x over n squared cosine nx. And then positive times negative, that's negative, and you have 8 over n cubed sine, why did I put sine x? It should be sine nx. Okay, and then the last line has to be multiplied and integrated, but in our case it's 0, so there's nothing coming out from the last line. And now all we have to do is plug in pi and 0. Don't forget to multiply the 2 over pi. I see that a lot when I grade papers. Often you get to this point, then you forget that we had the 2 over pi. So there's a 2 over pi. And now we just plug it in and then subtract. Okay. Let's see if you remember what we talked about last time. While going over the slides, I said that you don't have to take notes, but please do write these two. Sine n pi is equal to what? 0. Very good. How about cosine n pi? Negative 1 to the nth power. Yes. So for these, it's helpful if you just recall the graph of the sine and cosine. Sine goes from like 0 and then pi and then 2 pi and then 3 pi and then 4 pi. So every time you're at some integer multiples of pi, you're at the 0 point. Okay, so it's always 0 if n is an integer. And for cosine, you start from 1 at 0 and then goes to negative 1 when x is pi. And then it goes to positive 1 again, and it alternates between 1 and negative 1. So it's equal to this one because this also alternates between 1 and negative 1. Okay? And that's going to be something that we use a lot when we compute the Fourier series. So let's see, what do you get? You get, when you plug in pi to this one, what would you get? Sine of n pi, what's that? 0. If you plug in pi here, what do you get? Cosine n pi. That's negative 1 to the nth power. Right? Okay, so that's something non-zero. But how about this one? Sine n pi.
0.
That's 0. Okay. So you're going to get 0 for here, 0 for here. Non-zero, let's see what that is. So you have 2 over pi. And then you have 8 times, remember we're plugging in pi into x, so this is also pi, over n squared. And cosine n pi is negative 1 to the nth power. Okay. And then minus, now you have to plug in 0, right? If you plug in 0, what's sine 0? 0. What's cosine 0? 1. However, you're plugging 0 in here as well, right? So 0 times 1, so that's 0. If you plug in 0 here, you also get a 0. Okay? So hopefully you appreciate the fact that we use the evenness of the x squared to change the domain of integration from negative pi to 0 to pi, because when you plug in 0, it's a lot easier than plugging in negative pi. That's always a good idea, okay? So for when you plug in 0, you don't get anything, it's just zeros. Therefore, after canceling the pi's out, and then 2 times 8, that's 16, you get 16 over n squared times negative 1 to the nth power. That's what you get.
Professor,
Yes?
quick question. So why were we able to cancel out the odd, like the 5x, because it was odd?
Right. So I was talking about last time that x to the first power, or x to any odd power, is what we call an odd function. So if you look at the graph of 5x, it's like that. And if you integrate from negative a to positive a, these two sides cancel each other. And that happens for any odd function. If this happens, we call it an odd function. Okay?
So because of that,
Yeah. So if you're on a symmetric domain, you can make use of the even and oddness, which makes the calculation a lot easier. Okay. So now try Bn. I'll give you some time to do Bn. This will be this. First, identify which one will give you 0. And it's different this time because sine is an odd function, right? So this is even, that's odd, that's odd. When you expand, even times odd will be odd, whereas odd times odd, two odd functions multiply to give you an even function. So you can see which one's the survivor, right? Yes?
How do you determine when it's an odd or even? Is it the highest power?
So x to the odd power gives you, it's an odd function. X to an even function is an even function. On top of that, cosine nx or kx, k could be anything, this is even, whereas sine of kx is odd. What about constants? Constant functions, are they even or odd or neither? It's even, right? Yeah. Because if you have a constant function, a straight line can be folded over y-axis to match evenly, right? That's what an even function is. That's why we can do this trick of doubling the integral. We take the twice because the integration on the left side, the right side and the left side are the same. So you just integrate the right side only, and you double it. Okay? Here's a joke I always make. F of x equals to 3. Even or odd?
Even.
3 is?
even.
Even. Okay. Where did you learn that from? Dr. On's class. Okay. 3 is even. Yes?
What if there's like multiple, so sine is just distributed in there?
Oh yeah. So it's like if you have a single function, you can always make it as a sum of an even part and an odd part. So some portion of it will be even and some portion will be odd. So if you multiply them, you get 4x squared sine nx plus 5x times sine nx. And this is even times odd. If you multiply an even function with an odd function, you end up with an odd function. Whereas if you multiply an odd function times an odd function, you end up with an even function. And if you're not convinced, do take a graphing calculator to draw this one. You'll see that the graph indeed is symmetric over the y-axis. Okay. Now, if you are ever confused about the rule, then just think of an example. Like, take an even function. What's an even function example? X squared is the even function, right? Multiply by an odd function. What do you get? You get an odd function, right? But if you have an odd function and another odd function, you multiply, what do you get? You get an even function. Okay? Yeah, so what's confusing is that 3 is an odd number, but it's an even function. Okay? Yeah, so maybe you might have been confused because I was calling 5x as odd, and indeed 5 is an odd number, but that has nothing. This can be 6, and 6x is still an odd function. Okay? And it's all about shortcuts in integration. If you can make use of that, whenever your interval is symmetric, then you can use the even and oddness to reduce the computation greatly. Yeah, another common mistake that I see is like people using even and odd, even if the interval is like 0 to 3. Like I see people doing like this. Oh, that's an odd function, so this integral must be 0. Is that right? No, it's not right. Because it's only from 0 to 3. So it should really be 1/4 x to the 4th, 3, 0, which is 81 over 4. It's not 0. Only when you have negative 3 from positive 3, then it's 0, no question. So that's another common mistake people make. All right, so while accepting questions, I believe some of you were busy doing the calculation. Did anyone get an answer? Still working on it? Come on, that's too... You got something? Can you show it to me? What did you get? Oh, that's perfect. That's correct. Very good. Okay. All right. So let's try this together. So we know that this is the one that's not going to count, and odd times odd gives you even, and therefore this will be 2 over pi integration from 0 to pi of 5x sine nx dx, whose tabular would be plus minus derivative integral 5x 5 0 sine nx negative 1 over n cosine nx, and then negative 1 over n squared sine nx plus minus plus. And from here you should be able to read off that it's 5x times this and negative 5 times negative. Last line doesn't count. So you end up with the following: 2 over pi of negative 5x over n cosine nx. Negative times negative, that's plus 5 over n squared sine nx. You plug in pi and 0. And what happens if you plug in pi here? Yep. What happens when you plug in pi here? 0. Sine n pi is 0. When you plug in 0 in here because of this x, it's going to be 0. When you plug in 0 here, again, sine 0 is 0. So the only non-zero thing that you're going to get is when pi is plugged into the first one. Therefore, the answer would be 2 over pi times negative 5 times pi over n times negative 1 to the nth power. Pi and pi will cancel. 2 times negative 5 is negative 10 over n. And you get negative 1 to the nth power. So that's your Bn. So you found out A0, we found out An, you found out Bn. Now you have to write your answer. Okay? It just breaks my heart when some student does all these calculations and stops right there thinking that he or she had the right answer. Because that's like stopping right before the finish line. The final answer would be what? F of x equal to this over 2. So let's just divide this by 2. What do you get? 8 divided by 2 is 4, right? So you're going to get 4 over 3 pi squared plus sigma n equals to 1 through infinity of an is, what was it? It's 16 over n squared, negative 1 to the nth power, and then cosine nx plus, actually minus 10 over n, negative 1 to the nth power, sine nx. So that's the final answer.